Question number 5. Here question says that refer the figure. So we have to refer the figure to E1. Find the magnitude A part. B part is X and Y components and C part is angle with the X axis of resultant OA, BC and D. So we have to calculate to find out uh, three things. Now see here, there are a number of vectors on axis. So in order to find the resultant of all the vector, we must translate a vector with a common point. Okay, translation of a vector does not impact by its value of vector does not impact by its translation. So suppose this is the common point, that is O. So OA we can write here, this is vector OA, 2.0, 2.0. Now vector C, that is this is OA. Okay, now next vector is vector BC. So BC is parallel transfer to the common point O. So this is BC 1.5. Okay, and angle this is equal to 60 degree. Okay, now angle E, vector E is again we can write this as here. So this is vector E, angle is 90 degree and 1 meter. Okay, so parallel transfer of vector with common point, that is origin O. Now we have to find the resultant. So we can write here OA is equal to, in component terms, 2.0 cos 30 degree plus this is in I, the component of OA. So cos 30 degree, this one. Okay, OA. Okay, so cos 30 degree plus 2.0 sine 30 degree, that is J. Com Component of OB can be written in the component term, that is 1.5 with minus sign cos 60 degree I plus 1.5 sine 60 degree J. Okay, because this is in this angle, so component is along negative axis and x component or y component is along positive axis. Now OC is equal to, we can write here 0 I minus 1.0 z, because the vector OE, see here, vector this is OE not OC, vector O is along negative direction of y axis. So this is equal to, we can write here vector OA is equal to 2.0 multiplied by cos 30 degree. So cos 30 degree is 3 by 2i plus 2.0 sine 30 degree is 1 by 2j. So this is equal to root 3i plus j. OB is equal to, again we have to put the value, minus 1.5 cos 60 degree is 1.1 divided by 2. Okay, plus 1.5 sine 60 degree is root 3 by 2j. So we can write this as minus of 0.75 I. So this is in I. So minus of 0.7 I. Okay, plus this is 1.5, that is 0.75 into root 3 is 1.732 j, and OE, right, OE is equal to minus of 1.0 j. So here we have to find the magnitude of the resultant. So resultant is R. So this is equal to OA plus OB plus OC. So we have to add these three vector. So the corresponding x component and y component will be added in the resultant. Hence, this is equal to, see here, root 3 minus 0.75 I. Okay, plus for j component we have to right, this is equal to 0.75 into 1.732 minus 1. So we have to this is 1 and this is minus 1, so we have to subtract minus 1 into j. So this is the vector, that is a resultant vector. Now r is equal to, we have to calculate this one and this one, so we get 0.98 I, okay, 0.98 I plus 1.3 j. So this is the value of the calculation. See here, this minus 1 and this plus 1 is cancel out, so here minus 1 is not here, so this is the value of 0.75 into 1.73 is 1.30. So we get the resultant vector. Now resultant r is magnitude of resultant is square root of 0.98 raised to the power 2 plus 1.3 raised to the power 2. So once we calculate this one, we get the value under root, this is equal to 2.67, 2.67, and under root 2.67 is 1.6 up to 2 significant digit. Okay, so we get the value of the magnitude of the resultant vector, that is part A. Part B says x and y component. So x component of resultant, that is Rx, is equal to 0.98 and Ry is equal to 1.3 j. I hope this is clear to you. Now the last part is the angle with the x-axis. So we have to find, suppose angle is theta of the resultant with x-axis. So alpha, suppose this is angle alpha, so tan alpha is equal to 1.3 y component divided by x component. So when we divide it, we get the value up to 2 significant digits, that is 1.32. Hence alpha is equal to tan inverse 1.32. So these are the answer of the entire question. Very easy but conceptual. So be practice. Have a nice day. Jai Hind.